Winter 2015, question 8, QP11. The first term of a progression is 4x and the second term is x squared. I. For the case where the progression is arithmetic with a common difference of 12, find the possible values of x and the corresponding values of the third term. II. For the case where the progression is geometric with a sum to infinity of 8, find the third term. Okay, so in the problem that we just saw the first variant, question 8, we're saying that the first term of the progression is 4x. Okay, the first term of the progression is 4x and the second term is x squared. The I part is trying to situate or bring that 4x x squared situation in the case of an arithmetic progression. Okay, so let's see, for an AP, we can say that, so let's look at the AP case. Okay, so this is 4x is T1, so your T1 is your first term, as the problem rightly said, and x squared, the question said that it's your second term, so we call that T2. So in the case of the AP, as the I part suggested, says that if the common difference is 12, we want to find the possible values of x and the corresponding values of the third term. The common difference is 12. So basically, we're just trying to say that in the case of an AP, x squared minus 4x is equal to 12. That is your common difference. So you're going to have x squared minus 4x minus 12 equal to 0. So what happens here, we just try and solve it quadratically. Now, if you were to do quadratic, as you know in your basic algebra, your x is going to give you 6 and negative 2. Okay, 6 and negative 2. 6 and negative 2. So your x is going to give you 6 and your x is also going to give you negative 2. That is the relation in there for your x's. So for the possible values of x, we want to find the values of the third term. Okay, so if we want to find the third term, let's see what the third term will be. This is T3. And we are saying that the common difference is 12. So if the second term is x squared, then the third term is going to give you x squared plus 12. Hope you understand that, because the common difference is 12, which is positive. If we want to find the third term and we know the second term is x squared, you just add the common difference of 12 to the second term to give you the third term. So the third term is x squared plus 12. Hence, we need to find the values for the situation where x is equal to 6 and also for the situation where x is equal to negative 2. So the third term, okay, T3 will have two values. For x equal to 6, you're going to have 6 squared plus 12. And for x equal to minus 2, you're going to have minus 2 squared plus 12. And I'm sure that it should be easy for you to resolve that. So this should give you 48. Your third term could either be 48 in the case of x equal to 6, or your third term could be 16 in the case of x equal to minus 2. And that is what the I part helps us to achieve for that. In the second II part mentions that with the same preamble given, where your first term is T1 is 4x and your second term is x squared, we are being said that if it were a geometric progression, and the sum to infinity was 8, yes, we want to find the third term. So we know for a geometric progression that the sum to infinity, okay, is a over 1 minus r, where r is the common ratio. You understand that? The common ratio of a geometric progression, which we always achieve by dividing the succeeding term over the preceding term. So let's look at our r. Our r will have been x squared over 4x. Hope that is okay. All right, x squared over 4x. Now, when we resolve that, we are going to have this to be x over 4. So your common ratio is x over 4 if it were a geometric progression. Now, we know the first term to be 4x, so we just try and do the substitution. And the sum to infinity, they say, is 8. So we can say that our 8 is equal to 4x all over 1 minus x over 4. Okay? So when you're able to do this resolution, if you're able to resolve that, if you're able to resolve this, you are going to generate your x value, and that's a bit of basic algebra, so I'll just leave you to do that. You can just cross multiply all of that. When you're able to solve that, you will get your x being equal to 4 over 3. Guys, you get it. When you have your sum to infinity h being equal to the expression that we've just carved out, if you try to use your basic algebraic techniques to solve for x, your x should lead you to 4 over 3. So that is 4 over 3. So if your x is 4 over 3, what is going to be your third term? Remember that your third term, T3, is always your second term times your common ratio. Okay? All right, so with x being equal to 4 over 3, what is going to be our common ratio? Remember, the common ratio is x over 4. So our r is going to be 4 over 3 divided by 4. So your common ratio is going to give you 1/3. Hope you are fine. Your common ratio is going to give you 1/3. So when you have your common ratio being equal to 1/3, then your T3, as we've shown here, is going to give you x squared, which is 4 over 3 all squared, times your common ratio, which is 1 over 3. And when you do a resolution of that, you should be able to get 16 over 27. So 16 over 27, ladies and gents, is going to be the value of your third term in the event that you were looking at a geometric progression. So you have the solution for the question 8 of the first variant, where the I has got to do with an AP and the II has got to do with a geometric progression situation. I hope that is clear.